right, so this is a practice of rationalizing. And remember, rationalizing means that you can't have a root in the denominator. So to not have a root in the denominator, that means you have to multiply it by itself, because that's kind of like squaring and square rooting are the opposites of each other. Okay, so for example, if you've got the square root of 7/3, well, first we have to recognize, well, that actually is the same thing as the square root of 7 and the square root of 3. Okay? Well, when you do that, you realize, oh, well, I can't have a root right here. That's the definition. Okay, so let's write that off to the side. Cannot have a root. Okay, the denominator cannot have that root right there. So in order to get rid of it, you square it. Okay, you square it. But if you square it, that just means that I multiply it by itself. That is the square root of 3 squared. Okay? So you square it so that they'll cancel, but whatever you do on bottom, you have to do on top. Alright, because whenever you change fractions, you actually can't change it. So if you're trying to manipulate it, which is what we're doing, is we're messing with it so that it works out better for us, but you actually can't change it. So whenever you do something on bottom, you have to do it on top, because that's like saying the number 1. So you're not really changing it, it just is going to look different. Okay? So whenever I decide to multiply by the same thing on bottom, because that's the idea of squaring it, I have to do it on top right here, okay? So what happens is that square and that square root cancel, and you get the 3 to come out, okay? So let's also make sure that we note right here that these are the same, okay? You multiply by the same thing, and then these are also the same. Okay, so whatever this is, that's what you see all around. That's what you're multiplying by. Okay? But what you really could do is, instead of doing this canceling like I showed you, you can just multiply across square root of 7 times the square root of 3. That means you can put them together as the square root of 21. And then the square root of 3 times the square root of 3 is just the square root of 9. But we know that the square root of 9 is just the number 3. So just like when I canceled those out, I got a 3. You can multiply them and then root it, and you still get that 3. So if you just want to multiply it, it will work out. And if you notice, the radical is gone. There's no radical down there. And that's what we're trying to do. We're trying to get it so that there's no radical. Okay? All right, this other problem is where that word conjugate comes into play. Okay? Because that helps us cancel out the denominator. So if this is the original problem, then we want to multiply it by its conjugate. Now remember, conjugate meant that if this is a plus, then its conjugate is the minus. It's the exact same thing, except you are subtracting it. So it is 5 minus the square root of 3. And then whatever you do on bottom, you have to do on top. And I'm going to go ahead and make that a minus real quick. Okay? So just like these two were the same in this problem, these two are the same in this problem. Okay, whatever you multiply on bottom, you have to multiply on top. And the way we decided was that these are conjugates. So that's where that word, oh, I think it's a J. Let me look, I'm pretty sure. Yeah. Okay, so it's conjugates. All right. So the reason why we use conjugates is because what happens is the middle cancels out. In the past, we made our box and we would multiply our box and all of that. And we're going to do that when we start bringing in other types of problems. But for this one, I'll show you a shortcut. When you multiply, okay, let's look at just the top. When we do the top, we say 4 times each of those. So 4 times 5 minus the square root of 3. Okay, so we're going to distribute that in a second and we'll work that out. Well, the denominator is 5 plus the square root of 3 times 5 minus the square root of 3. And even though we should FOIL, even though we should use our box, every single time we do that, we actually have a shortcut. And what happens is, really, just first times first multiply and last times last multiply. Okay, because the middles cancel out. The outside and the inside cancel out. So, when we do this problem, you distribute 4 times 5, and we get 20. You distribute 4 times the square root of 3, which you cannot put them together. So you just write it as 4 root 3. It's kind of like as if root 3 were a variable. Okay? Then, here you just do the shortcut. You multiply the front, and you get 25. You multiply the back, and root 3 times root 3 is the square root of 9. Just like up here, we got the square root of 9. But the square root of 9 is actually a number. So instead of writing it as the square root of 9, just remind yourself, oh, well, the square root of 9 is actually a 3. Okay, so this 3 that we just multiplied comes out. And now we actually just subtract and we finish out our problem. So the answer is 20 minus 4 square roots of 3 over 25 minus 3 is just the number 22. Okay? It's just the number 22. And then this is actually a really good practice. We're actually going to be getting into this a lot, this unit. And that is, if you notice these numbers out front, this 20, this 22, and this 4, think of them as fractions, and they all can be reduced. They all have a common factor of 2. So if you can divide each of those by the same thing, you go ahead and you do that. So since they're all even, they can all divide by a 2, and that would turn into a 10. That would turn into a 2. Square root of 3 just tacks on. Remember, treat it like it's a variable. It actually, you can't deal with it like you do the other numbers. And then that reduces down to an 11. So even though this is kind of a crazy looking problem, this is actually what we're getting into. We rationalize the denominator. That helps cancel out the root. So it's just a number. If you notice, there's no root, there's no radical down there. But then I did want to point out that we've got to start practicing reducing. So since each of these numbers, these coefficients, is an even number, divide them all by 2 so that it reduces them. Okay? Alright, so we're going to practice that a little bit more. But let me just go ahead and pause that, and we'll go to the next, the last couple things. Okay?